If you write the code that way, it's the same as the code shown just before this example, and it yields a compiler error. This is one perhaps obscure example where the slight differences between arrays and pointers become obvious, but it does help explain why you can see something like this. Int main, int argc, char star star argv. If you write the code that way, it's the same as the code shown. Oh. And you are free to use the argv variable to access an array of pointers. Specifically, in this case, an array of character pointers, also called strings. Building constant arrays. If you have an array and you don't want its contents to change, you can make it a constant array. The following lines of code found in the array05 example demonstrate this approach. Constant permanent, open bracket 5, close bracket, equals, open curly bracket 1, comma 2, comma 3, comma 4, comma 5, close curly bracket, and semicolon. Hi Cigar, how are you doing? I'm doing okay. I'm just continuing on with my reading of C++, All-In-One For Dummies. This is book 4, chapter 1. Hopefully I can end it. Hi, Monica. In California. Oh, Mr. Holmes is back. Okay. Okay, if it gets helper review, it's gonna stay in review land and or hold land. The point is I don't review those. Okay, I'm gonna continue on with reading time. Oh, from India, awesome. Oh, my brain cannot handle some things. I want to say it's like Hyperabad, but with a D instead of a P. But it's probably Hyderabad. No, it's Hyderabad. But it could be bad. Hyderabad. Something like that. I'm from California, United States. Let's see. This is just reading time, effectively. Last time was only like 20 minutes of reading time and mostly 40 minutes of snack time, but I'm done with snack time, so reading time. Okay, see out, fine. Since people are here who might care, I'll show the book for these parts with the code. All right, const int 5 1 2 3 4 5 C out permanent 1 in line. Okay, that's the part. I'm like sort of just vibing and keeping it kind of mellow and chill, so I'm just trying to stay awake too. So I'm just kind of just trying to be comfy, but still get in some reading time. This array works like any other array, except you cannot change the numbers inside it. If you add a line like the following line, you can compile an error because the compiler is aware of constants. So in this case, it says permanent with the opening bracket and then 2 and the closing bracket equals 5, semicolon. And so the compiler does not like that, because it's saying, hey, you're trying to change a thing that's supposed to not be changed. Here's the error we got when we try this in code blocks. Error assignment of read only location, permanent 2. Being the inquisitive sorts, we ask ourselves this question: what about a constant array? Of non-constants. Can we do that? Well, sometimes, depending on the compiler, as horrible as the following code found in the array 06 example looks, and it's not ANSI standard, you're allowed to do this with older versions of the GCC compilers. Microsoft Visual C++ and Borland C++ Builder don't allow it, and the CodeBlox compiler presents you with an error. Valid array assignment error message. So let's see. Oh yeah, Ryan, are you actually here, or did you just come by to say my name a lot and bounce? Because I'm seeing a 0, so I wouldn't know. Both things are likely. Equally likely, 50-50 on that one. Okay, so Light. Oh, you're here. Hi. Well, I'm glad you're able to make this one. It's definitely not the most popular thing on YouTube, so other people have other ideas of what to do with their time, and I get it. Okay, let's see. So, error assignment of read only, etc. Int non-constant 5, 1, 2, 3, 4, 5. Int other list 5, 10, 11, 12, 13, 14. Other list equals non-constant. In other words, maybe not. Yeah, I hear you. Okay, let's see. I am just going full mode right now. I mean, not full. I'd be asleep if it was full. I'm trying to avoid being asleep right now, honestly. We'll see. In other words, the third line says, saying, forget what other list points to. Instead, make it point to the first array, 1, 2, 3, 4, 5. Now, we really don't recommend writing code like this. Remember keeping things simple and understandable. So, if you want to prevent this kind of thing, you can make the array constant. Const int non-const 5. Okay. Open bracket 5 close bracket equals open curly brace 1, 2, 3, 4, 5, close curly brace, semicolon. I don't know which one takes longer. Const int other list bracket open 5 close bracket equals curly open curly bracket 10, 11, 12, 13, 14 with a space with a close curly bracket and a semicolon. Now when the compiler gets to the third line, it gives us an error. Error, assignment of read-only variable other list. But you may notice that this way we made the array constant. The way that we made the array constant was the same way that we made its elements constant in the code that came just before this example. Oops, what's that all about? Turns out there are some rules. Remember, the following list describes the rules for making arrays constant. If you want to make an array constant, you can precede its type with the word const. When you do so, the array, const spelled C-O-N-S-T. When you do so, the array name is constant, and the elements inside the array are also constant. Thus, you cannot have a constant array with non-constant elements, nor can you have a non-constant array with constant elements. The notion of a non-constant array exists only in GCC and is not ANSI standard. ANSI spelled capital A, capital N, capital S, capital I. Technical stuff. If you really want to get technical, the C++ ANSI standard says that when you put the word const in front of an array declaration, you're not making the array constant, you're saying that the array holds only constants. Yet, when you use const this way, most compilers also make the array itself constant. But that's fine. People shouldn't be taking an array name and copying it to something else. That's not good programming style, and it's just asking for bugs, or at the very least, confusion later. Okay, let me just check. I think there's only like 10 more pages in this chapter. Just about that. Alright, if I can just finish this chapter tonight, I would be like super happy. Pointing with pointers. To fully understand C++ and all its strangeness and wonders, you need to become an expert in pointers. One of the biggest sources of bugs is when programmers who have a so-so understanding of C++ work with pointers and mess them up. But what's bad in such cases is that the application may run properly for a while and then suddenly not work. Those bugs are the hardest bugs to catch because the user may see the problem occur and then report it. But when the programmer tries to reproduce the problem, he or she can't make the bug happen. It's just like when you take your car in to be fixed and suddenly it doesn't misbehave. Both the car repair person and the programmer would say, "Worked fine when I tried it." How frustrating is that? In this section, we show you how you can get the most out of pointers and use them correctly in your applications so you won't have these strange problems becoming horribly complex. Sounds like me a lot of the time during grad school and getting into grad school because I don't know why I can't seem to do easy solutions. Okay, we're not making this up. We have seen a function header like this. Okay, let's try to show. Oh, that actually worked. What? Okay, here. Void my function char star 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 a. Okay. Yikes! What are all those asterisks for? Looks like a pointer to a pointer to a pointer to ... something. How confusing. Now we suppose that some humans have brains, they're more like computers, and they can look at that code and understand it just fine. Not us. So don't worry if you don't either. So, to understand the code, think about this. Oh no, you're not a dummy, I got the same problem. That's why I always have to like make review my pointer stuff before I try to do C or C sharp or like anything that's going to require me to do pointers. I always have to review it. It's nothing wrong with being cautious. So to understand the code, think about this. Suppose you have a pointer variable and you want a function to change what the pointer variable points to. Now be careful. We're not seeing that the function wants to change the contents. And also, hey, this is a For Dummies book. I like it. Again, I am a dummy too. I love how they keep it simple though. That's my main thing. And they make it interesting. That's the thing. When you don't have to use it, there's no reason. I mainly got introduced to pointers when I had to do the C, when I was learning C. And then you have to use some pointers to be able to manage things. But outside of having to learn about C, and I know I had to use some pointers when I was working with C++ last year. I swear, too much going on. Well, anyway, now be careful. We're not saying that the function wants to change the contents of the thing that it points to. Rather, we're saying that the function wants to make the pointer point to something else. There's a big difference. So how do you do that? Well, anytime you want a function to change a variable, you have to either pass it by reference or pass its address. And this process can be confusing with a pointer. So what we like to do is take a detour. First, we define a new type using our friend, the type-def word. It goes like this, as shown in the pointer 01 example. Okay, I'm about to show that. So, Arduino. Oh, that's cool. Yeah, that's why, because C is a language that is small and easy to use in an embedded system such as that. It's small but mighty sort of thing. But yeah, you got to be careful with the pointers. There's things go wrong. That's why Java doesn't let you be able to really play around with them, really handle everything for you. It's all about the kids club. That's why they start people off with Java when they're first learning computer science. Okay, so I'm trying to point to the printer. Type def char pchar star pchar. This is a new type called pchar that is equivalent to char star. That is, pchar is a pointer to a character. Now look at this function. Void my function pchar ampersand x. X equals new char, and it has single quotes, says single quotes, pair, what have you, with the capital B inside. This function takes a pointer variable and points it to the rest of new char B. That is, it points to a newly allocated character variable containing the letter B. Now think this through carefully. A pchar simply contains a memory address. Really, we pass it by reference into the function, and the function modifies the pchar so that the pchar contains a different address. That's it. That is, the pchar now points to something different from what it previously did. To try out this function, here's some code you can put in main that tests my function. Char star pointer equals new char a with the single quotes. Char star copy equals pointer my function pointer. C out pointer points to star pointer and line. C out copy points to star copy and line. Think it through carefully. The first line declares if char is the same as pchar, The first line also allocates a new character A on the heap. The first line also allocates a new character A on the heap and stores its address in the pointer variable. The second line allocates a second variable. Okay, so my Verizon is being too weird. So I just connected my Wi-Fi. I don't have anything going on as far as videos or whatever, so hopefully that'll be good. Next we call, yeah, my network, my Verizon network was not doing good things. So hopefully this is better. Next we call my function. That function is supposed to change what the pointer points to. Then we come back from the function and print two characters. The character that pointer points to and the character that copy points to. Here's what we get when we run it. PTR space points to B, copy points to A. This means that it worked. The pointer variable now points to the character allocated in my function, which has a parentheses and then a lowercase a, uppercase B, close parentheses, while the copy variable still points to the original capital A. In other words, they no longer point to the same thing. My function managed to change what the variable points to. Now consider the same function, but instead of using references, try it with pointers. Here's a modified form as found in the pointer02 example. Void another function p char star x equals new char capital C. Now, because the parameter is a pointer, we have to dereference it to modify its value. Thus, we have an asterisk at the beginning of the middle line. And here's a modified main that calls this function. I remember that part when I was doing, this time last year when I was doing advanced object-oriented programming. It is good to be able to dereference things, pointers as you need to, or like be able to change something from being const with non-const. That's nice to be able to do that. So it says the modified main char star pointer equals new char A, char star copy equals pointer, another function ampersand pointer, see how pointer points to star pointer in, copy points to star copy, inline. Because our function uses the pointer rather than a reference, we have to pass the address of the pointer variable, not the pointer variable directly. So notice the call to another function has an ampersand, which is the at symbol. I mean, the and symbol in front of the pointer, in front of the PTR, which means pointer. And this code works as expected. When we run it, we see this output. PTR points to C, new line, copy points to A. This version of the function called another function made a new character called C, and indeed it's working correctly. Pointer now points to a C character while copy hasn't changed. Again, the function pointed PTR to something else. Now we can unravel things. We created a type def, and honestly, we would prefer to keep it in our code because we think that using type def makes it much easier to understand what the functions are doing. However, not everybody does it that way. Therefore, we have to understand what other people are doing when we have to go in and fix their code. We may have to too. So here are the same two functions, my function and another function, but without type def, which is what I'm used to doing. Instead of using the new pchar type, they directly use the equivalent char star type. Okay. Void my function char star ampersand x. X equals new char b. Void another function char star star x. Star x equals new char c. To remove the use of the type defs, all we did was replace the pchar in the two function headers with its equivalent char star. You could see that the headers now look goofier, but they remain exactly the same as before. The first is a reference to a pointer, and the second is a pointer to a pointer. But think about char star star x for a moment, because char star is also the same as a character array in many regards. Char star star x is a pointer to a character array. In fact, sometimes you may see the header for main written like this. Int main int argc char star star argv instead of int main int argc char star argv with the brackets. Notice the argv parameter in the first of these two is the same type as we've been talking about, a pointer to a pointer, or in a more easily understood manner, the address of a pchar. But you know that the argument of main is an array of strings. So bear with us and follow this somewhat convoluted thought. Go slowly if you have to. What if you have a pointer that points to an array of strings, and you have a function that is going to make it point to a different array of strings? Better type def this one. It's going to get ugly. And just as a reminder, we're still using the previous type def pchar too, as shown in the pointer example. So it says type def char star star string array type def char star pchar. Make sure that you believe us when we tell you that string array is a type. Well, Ryan, I'm sorry, but it's the week. I don't tend to have a lot of energy for dancey time during the week. I was trying to do shorts yesterday, but my boyfriend and I, we were trying to figure out the lighting a little better, and we're working on it. And it came out great for the TikToks. It's not quite there, And by the time everything was said and done, I was just too tired to try to do anything for YouTube. But I guess I could end the stream with some dancing. Oh, but I also don't like to worry about copyright. So I'd probably just have to start a new stream, which would be my third today, because I already did an hour, which was consistent mostly of me eating for 40 minutes. I didn't think it was going to take that long. That's not typical for me. Too busy talking. And then doing some reading for like 20 minutes. So I could try and do some dancing, but it's going to be after I try to finish this chapter. And probably in a new stream. And it's going to be, did I mention the part about it's only like 20 minutes because I have like no energy? Okay, make sure that you believe us. Okay, there's like 10 pages left. Okay, I can randomly dance all I want inside. I have privacy I need to keep. Make sure that you believe us when we tell you. Also, I work too much like retail to be like thinking that that's a really great idea to just suddenly be at a Target or whatever and busting a move. Like, no, that's okay. Make sure that you believe us when we tell you that string array is a type equivalent to an array of strings. In fact, when you put these two lines of code before your main, you can actually change your main header. Ooh, sure. Let's do the following and it will compile. Okay. Int, oh come on. Int main, int argc, string array, argv. Now, here's a function that will take as a parameter an array of strings, create a new array of strings, and set the original array of strings to point to this new array of strings. Whew. Oh, it's possible, but then I gotta worry about their privacy. See how this just ends up being a big kind of problem for privacy? Oh, bummer. Oh, but on that note, when I go visit my family, I'll be dancing it up. They're usually just politely looking the other way and just on their phone and not making comments. But sometimes my niece will join me if it's like some Just Dance. Depends on the song. That's nice. Make sure that you believe us. Sometimes my nephew too. Yeah, that was a fun time. Make sure that you believe us when we tell you that the string array is a type equivalent to an array of strings. In fact, blah, blah, blah. Now here's a function that will take as a parameter an array of strings, create a new array of strings, and set the original array of strings to point to this new array of strings. Okay, I had to read that one because that was like, I still didn't quite process that one, but that's okay. Yeah, that's the number one problem I had with grad school and getting grad school was definitely the reading. Like my brain just gets to the point where it's like, what? And I don't want to read the same half a page 50 times. I'm just better just trying to do it and then go get whatever error I need to and then go through the steps of trying to clear it. And or asking teacher, not to say I don't try to do reading, just really doesn't stick. Hello, now I'm having orientation issues. Come on. All right, avoid change as reference string array, ampersand array. So it's taking the reference of array. String array, name array equals new pchar, size 3. Name array 0 equals Tom. Name array 1 equals Susie. Name array 2 equals Harry. Array equals name array. Just to make sure that it works, here's something you can put in main. String array origin list equals new pchar 3. Origin list 0 equals John. So they're doing the Beatles. Let's put it that way. String array copy list equals origin list. Well, not Ringo though. All the bingo, all the all the pieces for Ringo, all the bingos. Goodness. Um, change as reference origin list. C out origin list 0 in lines 2. Out origin list 1. Okay, so they're just all of those things. They're printing them out. So they're trying to make sure if the original list stays at John, Paul, and George, and the copy of the list should likely go. It depends on what they made copy. I feel like it's going to be ending up in the same result because this is the original list and they just copied that list. But we'll see. This time, yellow submarine, I hear that. I had the Beatles number ones, and I used to play the heck out of that album. And that was fun to dance to, I gotta say. Good times. Okay, string array origin list equals new picture, especially like Eleanor Rigby. I forgot Lonely People, I think, something like that. String array origin list equals new picture and blah blah blah. Alright, this time in main we're using that's just a part where I could just not do that. This time in main we're using the type def. Oh, okay. I was wondering. Okay, this time in main, we're using the type def types because frankly, the code is getting a bit confusing, and that helps keep what we're doing clear. I like clear. That sounds great. Note that we first create a pointer to an array of 3 strings. Then we store 3 strings in the array. Next, we save a copy of the pointer in the variable called copy list. Uh-oh. And we print all the values. Now, when you run this main, you see the following: Tom, Susie, Harry, John, Paul, George. Okay, I have to check. I gotta text my boyfriend so I'm gonna just check. So we're talking about the names? Okay. The first 3 are the elements in origin list, which we passed into the function, but they no longer have the value John, Paul, and George. 3 original Beatles names have been replaced by 3 new names, Tom, Harry, and Susie. However, the copy variable still points to the original string list. Thus, once again, it worked. We managed this change from John, Paul, and George to Tom, Susie, and Harry by reference, but you can also do it with pointers. Here's the modified version of the function, this time using set pointers as shown in the pointer 04 example. As before, oh sorry. Whew. Void, oh my goodness, I'm gonna try and drink. Okay. Void change as pointer, string array star array, string array name array equals new PC chart 3, name array 0 equals Tom, name array 1 equals Harry, name array 2 equals Susie, star array equals name array. As before, here's the slightly modified simple code that tests the function. String array, origin list, etc. John, Paul, and George, etc. And they say it was modified. This is talking about new pchar. Is that what's modified? No. Okay, this is the original. I'm just tired, so I'm not really being as observant as I could be. And this is the quote unquote modified. So you can tell me, or just you on your own time. I'm too tired. All right. So you can see that when we call change as pointer, we're passing the address of orange list. The output of this version is the same as of the previous version. And now, as before, we unravel all this. Here are the two function headers without using the type defs. Int changes reference char star star ampersand array, and int changes pointer char star 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 array. We have seen code like these two lines from time to time. Such code isn't the easiest to understand. But after you know what these lines mean, you can interpret them. Tip. Our preference is to go ahead. Our preference Our preference is to go ahead and use type def, even if it's just before the function in question. That way, it's much more clear to other people what the function does. You are welcome to follow suit, but if you do, make sure that you're familiar with the non-type def version, so you understand that version when someone else writes it without using type def. Or if that person says to you, this function takes a pointer to a pointer to a pointer. Yes, we've heard people say that. Pointers to functions. When an application is running, the functions in the application exist in the memory. So just like anything else in memory, they have an address. And having an address is good because that way people can find you. You can take the address of the function by taking the name of it and putting the address of operator, which is the ampersand, in front of the function name, like this. I think I'm gonna have to end the stream. Yeah. Hey, is that you, Ryan? Are you back or are you gone? Okay, address equals star. Ampersand my function. But to make this work, you need to know what type of declare address. What type to declare address. The address variable is a pointer to a function, and the cleanest way to assign a type is to use a type def, as shown in the function pointer 01 example. Fortunately, this is one time when most people are willing to use a type def. Here's the type def, believe it or not. Cold? Yeah, but oh, you're back. Okay, hold on. Sorry, I wasn't trying to get my foot. Type def int star function pointer int. It's hard to follow, but the name of the new type is function pointer. I don't really like heaters. It stays kind of cool in my apartment, even when it's like warm outside. And I'm just not really a fan of heaters, so I'd rather just layer up. It's hard to follow. It's California, so it's not like I'm going to freeze. I don't live by snow. There are some parts in California that snows, but I don't live on those. It's hard to follow, but the name of the new type is function pointer. This defines a type called function pointer that returns an integer, the leftmost int, and takes an integer as a parameter, the rightmost int, which must be in parentheses. The middle part of the statement is the name of the new type, and you must precede it by an asterisk, which means that it's a pointer to all the rest of the expression. Also, you must put the type name as preceding asterisk inside parentheses. And then you're ready to declare some variables. Here goes. Okay, let's do that. Function pointer address equals ampersand my function. So that's handy. You can point to an array. You can point to, technically a pointer and array are kind of similar. You can point to pointer, you can point to a function. It's great. The line declares address as a pointer to a function and initializes it to my function. Now for this to work, the code for my function must have the same prototype declared in the type def. In this case, it must take an integer as a parameter and return an integer. So for example, you may have a function like this. Int the secret number, int x, return x plus 1. Then you could have a main that stores the address of this function in a variable and then calls the function by using the variable. Int main, int argc char star argv, type def int, star function pointer int passcode equals 20, function pointer address equals ampersand the secret number, cout address my passcode in line. Now just so you can say that you've seen it, here's what the address declaration would look like without using a type def. Int star address int, so that's the one I'm used to using, equals ampersand the secret number. Oh, I'm more into dogs, but only because I have super worse allergies when it comes to cats. But also, it's nice to be light. Cats don't seem to like people so much. Dogs do. I don't know. Pointing to a variable to a mirror function. It's surprising to find out that most C++ programmers have no idea that a pointer called this THIS exists. So this THIS is a big secret. Revel in it. What is the secret? The secret is that you can take the address of an object's member function so that you can access the member function instance data directly. Ooh-wee. Now, remember that each instance of a class gets its own copy of the member variables, unless the variables are static, but functions are shared throughout the class. Yes, you can distinguish static functions from non-static functions, but that just refers to what types of variables to access. Static functions can access only static member variables, and you don't need to refer to them with an instance. Oh, that's good to know. Okay. No, I think this was one of the things I was having trouble with at some period. Non-static, that is a normal regular member functions, work with a particular instance. However, inside the memory, really only one copy of the function exists. So how does the member function know which instance to work with? A secret parameter gets passed into the member function, the this pointer. Suppose you have a class called gobstopper. Ooh, Wonka, that's fun. That has a member function called chew. Next, you have an instance called mygum, and you call the chew function like so. Mygum dot chew. When the compiler generates assembly code for this, it actually passes a parameter into the function. The address of the mygum instance, also known as the this pointer. Therefore, only one chew function is in the code, but to call it, you must use a particular instance of the class. Because only one copy of the chew function is in memory, you can take its address, but to do so requires some sort of cryptic looking code. Here it is, quick and to the point. Suppose your class looks like this. Class gobstopper public int which gobstopper int chew string name cout which gobstopper inline cout name inline return which gobstopper. The chew function takes a string and returns an integer. Here's a type def for a pointer to the chew function. Type def int gobstopper star god gob member string. And here's a variable of the type gob member. Gob member func equals ampersand gobstopper chew. If you look closely at the type def, it looks similar to a regular function pointer. The only difference is that the class name and the two colons precede the asterisk. Other than that, it's a regular old function pointer. But whereas a regular function pointer is limited to pointing to functions of a particular set of parameter types and return type, this function pointer shares those restrictions but has a further limitation. It can only point to member functions within the class gobstopper. To call the function stored in the pointer, you need to have a particular instance. Notice that in the assignment of func of UNC and the earlier code, there was no instance, just the class name and function ampersand gobstopper chew. So to call the function, grab an instance, add func, and go on. The function pointer 02 example, as shown in listing 1-2, contains a complete example with the class, the member function address, and two separate instances. Okay, I'm going to check on my boyfriend's text, the most recent one. I'll be back. Oh yeah, that's version. Listing 1-2. Okay. Oh, you're heading out, Ryan? Alright, good night. I'm trying to make it. I'm on 448 and the end of the chapter is at 453. So I think I can make it, and then I'm probably going to call it on this room. Oh, hold on, but weren't you trying to see some dancing? Are you sure you gotta bounce right now? Because I was planning on trying to do like 20 minutes in a new stream, 20 minutes of dancing. But if you're not interested, I don't have to do that. let's see, 1-2, taking the address of a member function, hashtag include IO string, stream, hashtag include string, using namespace standard class, gobstopper, public int, which gobstopper, into string name, C out which gobstopper inline, C out name inline, return which gobstopper, int main, type def, int gobstopper. See, this is interesting because I think type def is something that's also in JavaScript, if I'm not wrong. But I just might be I've learned this with C++ and just forgot that part. That's possible. See, type def int gobstopper : star gob member string gob member func equals ampersand gobstopper : true gobstopper inst dot which gobstopper equals 100 gobstopper another dot which gobstopper equals 20 inst dot star func greg dot w another dot star func Jennifer w return 0. No, I didn't leave. No, I just had to check on the text. Actually, I'm about to close out this reading, and then I can close this stream out. But then I will do a dancing stream if you are interested in checking that. But if you're not interested, I don't have to do the dancing stream. It's great. But no, I'm not gonna. I just had to. When I leave the app, it does things that involve messy at the live stream. Okay. Okay. You can see in me that the first we create the type. At least this time I remembered to No, I didn't. No, it was literally a text break. My boyfriend, he was giving me some really good advice on how to try to set the lights up. So he's interested to know how things went with those videos, the ones I was talking about. I don't know if you're here for that. The TikTok videos that featured the new light situation. And so I was trying to tell him how the performance, not only the performance between now and earlier today, but also the performance of those two videos compared to the two videos prior to that. So definitely a noticeable difference in views. So that's cool. Probably likes to, but I'm not trying to go that extreme with it. Sleepy. You can see in main, but I will, if you're interested, for 20 minutes of dancing, I could do a separate stream so I can, but it'd be Tuesday grooving. That's the tricky part. I have to come up with grooving songs. It's not impossible. There are a lot of grooving songs, but all the more reason to make it a separate thing so I don't have to worry about copyright. Because it's interesting, as I think it is to dance to no music, I can understand if people are like, because when I first was doing Twitch, I tried to do it with the music muted and just do the dancing, but that didn't exactly catch on too well. So then that's when I started doing the TikToks and then eventually YouTube Shorts. And then I'm like, well, let me try to see what I can do with whatever, having music. Let's test that out. See how cranky YouTube gets, etc. You can see in main that first we create the type def for the function, which we call gob member, and then we create a variable func of that type. Then we create two instances of the gobstopper class, and we give them each a different which gobstopper value. Finally, we call the member function first for the first instance and then for the second instance, just to show that you could take the addresses of functions with parameters we pass in a string with some names. When you run the code, you can see from the output that it is indeed calling the correct member function for each instance. So 10 followed by Greg W, followed by 20, followed by Jennifer W. Now, when we say the correct member function for each instance, What we really mean is that the code is calling the same member function each time, but using a different instance. If you're thinking in object-oriented terms, consider each instance as having its own copy of the member function. Therefore, it's okay to say the correct member function for each instance. And if I remember correctly, that's kind of like that functionality of how that works comes into play a lot when you're considering design patterns. Pointing to static member functions. A static member function is, in many senses, just a plain old function. The difference is that you have to use a class name to call a static function. But remember that the static member function does not go with any particular instance of a class. Therefore, you don't need to specify an instance when you call the static function. Here's an example class as shown in function pointer 3 example with a static function. Oof. Okay, I'm hanging in there. I think I can do this. Just like 3 pages, 4 pages away, something like that. Okay. I'm just so tired. Okay. Public. It was actually a good day. And I didn't have to do any rush hour traffic, but I guess I'm still kind of tired from those 2 hours of dancing that I did on Sunday. Static string, my class name, return gobstopper, int which gobstopper, int choose string name, see out which gobstopper inline, see out name inline, return which gobstopper. And here's some code that takes an address of the static function and calls it by using the address. Okay. Type def string star static member static func equals ampersand gobstopper : my class name see out static func inline. Note that in the final line we didn't have to refer to a specific instance to call static func, and we didn't need to refer to the class either. We just called it. Because the truth is that deep down inside, the static function is just a plain old function. Yeah, I hear you. I will. I'm just trying to get this done. And if you're interested, 20 minutes of dancing. After I close the stream, start a new stream, do 20 minutes of dancing. This would be my first time attempting to do Tuesday Groovin' live, but we could try it. Whew, okay. Referring to references. In this section, we reveal all the ins, outs, upsides, and downsides of using references, and we tell you a few things about them too. We're assuming in this section that you already know how to pass a parameter by reference when you're writing a function. For more information about passing parameters by reference, see Book 1, Chapter 7. But you can use references for more than just parameter lists. You can declare a variable. I know, right? So in my case, I might get woke up, but thankfully, my asthma pill is one of those makes me drowsy kinds of pills. So that'll probably be fine. But I'm seeing, I think I kind of overdid it a bit on Sunday, where I was totally wrapped up and going while I was doing it, but I'm having some side effects. You can declare a variable as a reference. Use references for more than one parameter list. You declare a variable as a reference type. Hold on. But you can use references for more than just parameter lists. You can declare a variable as a variable type. And just like job references, this use of references can be both good and devastating. Yeah. So be careful when you use them. Reference variables. Declaring a variable that's a reference is easy, whereas the pointer uses an asterisk, the star, the reference uses an ampersand, the and symbol. But there's a twist to it. You cannot just declare it like this. There's my foot, probably. Okay, good. So you can't just declare it like this. Int ampersand best reference. Nope, this won't work. If you try this, you see an error message that says best reference declared as reference, but not initialized. That sounds like a hint. Looks like you need to initialize it. Yes, references need to be initialized. As the name implies, reference refers to another variable. Therefore, you need to initialize the reference so it refers to some other variable. Like so, as shown in the reference 01 example. Int I'm somebody. Int ampersand best reference equals I'm somebody. Now, from this point on, forever, to the end of eternity, or at least as long as a function containing these two lines runs, the variable best reference referred to, that is, be an alias for I'm somebody. And so, if you type best reference equals 10, then you'll really be setting I'm somebody to 10. So take a look at this code that could go inside a main. Int I'm somebody. Int ampersand best reference equals I'm somebody. Best reference equals 10. See out I'm somebody in line. When you run this code, you see the output 10. That is setting best reference to 10 caused I'm somebody to change to 10, which you can see when you print out the value of I'm somebody. That's what a reference does. It refers to another variable. Remember, because a reference refers to another variable, that implies that you cannot have a reference to just a number. As in int ampersand x equals 10. And in fact, the offending line has been implicated. You are not allowed to do that. You can only have a reference that refers to another variable. Returning a reference from a function. It's possible to return a reference from a function, but be careful if you try to do this. You do not want to return a reference to a local variable within a function, because when the function ends, the storage space for the local variable goes away. Not good. But you can return a reference to a global variable, or if the function is, okay, that explains some of the errors I was getting last year. Yeah, things kept like poofing, and I was like, why is it poofing? I don't understand. Oh, okay. But you can return the reference to a global variable, or if the function is a member function, you can return a reference to a member variable. First example, here's a class found in the reference 02. For example, here's a class found in the reference 02 example that has a function that returns a reference to one of its variables. Ooh. Yeah. I kept trying to okay, because I remember effectively you have to be able to take a thing and pass it out of what you're in, be able to pass it out, and they kept being like, this doesn't exist, this isn't here. It's like, oh, okay, so how to work on that. But okay, now this makes sense. Okay, great. All right, let's see. This is what I'm saying. This is why I'm glad I'm reviewing this now that I'm done with grad school and I have a time to actually think about it. Okay, you're gonna have to help me with what you mean by FTW again, tired, sleepy times. What? What's FTW? For the win? Oh, is that for the win or is that a different thing? So, oh, it is. Okay, great. Great, thanks. It's like, oh, okay, that sounds familiar. All right, so we saw the 10, return the reference. I'm not on the right page anymore. Here we go. Class, dig into, private, int, secret, public, dig into, secret equals 150, int, ampersand, get secret variable, return secret, void right, see out secret inline. Notice the constructor stores 150. I could just do this forever. Notice the constructor stores 150 in the secret variable, which is private. The get secret variable function returns a reference to the private variable called secret, and the write function writes out the value of the secret variable. Lots of secrets here, and some surprises too, which we tell you about shortly. You can use this class like so. Um, int main, int argc, char star argv, dig into inst.write, int ampersand PRY equals inst.getSecret variable, PRY equals 30, inst.write, return 0. When you run this, you see the following output: 150, 30. Oh, no. Oh, yes. No, but yes. Okay, we're almost there. Ah. Okay, let me just handle the box real quick. That usually just involves me reading nicely without showing things. Referring to something else, hold on there. And now for the $1 million question. After you have a reference referring to a variable, how can you change that reference so it refers to something else? Brace yourself for a wild answer. Here goes. You can't. Yes, it's true. And yes, you may know some people who, nevertheless, have managed to do it. Here's the whole story. Hold on a second. I gotta read that again in my head. Oh, okay. Back when C++ first came out, companies that made compilers gave their compilers some sophisticated capabilities in terms of references. Many of them let you unseat a reference, that is, make the reference refer to something else. But lo and behold, when the ANSI standard came out in the late 1990s, the standard outlawed this practice. So now the rule is that you cannot unseat a reference. Further, you cannot have a pointer to a reference, nor can you have a reference that refers to another reference. This somewhat restrictive rule actually resolves some ambiguity. Suppose you wrote a line of code asking for the address of a reference with the hope of storing it in a pointer to reference variable. Because a reference refers to another variable, does that mean you want the address of the other variable, or do you somehow want the address of the reference itself? The standard clears this up. You don't have a pointer to a reference. But interestingly, older versions of the GCC compiler do let you write code that seems to take the address of a reference. However, in fact, you are taking the address of the variable the reference refers to. So again, no pointers to references. And that means you can't even take the address of a reference. Ooh, okay. Oh yeah, I'm supposed to chapter in case we're almost done with this lecture for this, but I can do a dancing stream. But I will need break time briefly just so I can need your time, but not involving what you were talking about. Okay. The first line is the value in the secret variable right after the application creates that instance. But look at the code carefully. The variable called pry really is a reference. Oh, that is pry. Is a reference to an integer, and it gets the results of get secret variable. And what is that result? It's a reference to the private variable called secret, which means that pri itself is now a reference to that variable. Yes, a variable outside the class now refers directly to a private member of the instance. After that, we set pri to 30. When we call right again, the private variable will indeed change. Is it just us, or does that seem like a bad idea? We made the variable private, and now the getSecret variable function pretty much wiped out any sense of the variable actually remaining private. The main function was able to grab a reference to it and poke around and change it however it wanted, as if it were not private. Trouble in C++ land. That's the problem with references. They can potentially leave your code wide open. Therefore, think twice before returning a reference to a variable. Here's one of the biggest risks. Somebody else might be using this code. See, this is a good thing to keep in mind. What? No, nobody's doing what? Where's your mind at? Goodness. Okay. Somebody else might be using this code, may not understand references, and may not realize that the variable called pri has a direct link to the private secret variable. Such an inexperienced programmer might then write code that uses and changes pri without realizing that the member variable is changing along with it. Later on, then, a bug results, a pretty nasty one at that. Tip. Because functions returning references can leave unsuspecting and less experienced C++ programmers with just a wee bit too much power on their hands, we recommend using caution with references. No, don't. What? Typo. No, you don't have to avoid them altogether. We suggest just plain being careful. Use them only if you really feel you must. But remember also that a better approach in classes is to have member access functions that can guard private variables. However, now that we've issued the usual warnings, references can be very powerful provided you understand what they do. When you use a reference, you can easily modify another variable without having to go through pointers, which can make life much easier sometimes. So please use your newfound powers carefully. What did you miss? I didn't do anything. Reading? I assumed it was reading, but that being said, I just finished book 4, chapter 1. Yay, I reached the goal. Great. Okay, preview. Chapter 2 is called Creating Data Structures. Oh, data structures, yay. I got a lot of practice. Ooh, that was a concept that was between the classes I took and the exam I took like three times. Thankfully, I passed it the third time. Oh boy, so much wonderful time with data structures. But now I get to do data structures without having to. I screamed out about something. Oh, I'm sorry. I'm not really sure. Sometimes it's just dramatic. I might have just been being dramatic. Sorry. Okay. Book 4, chapter 2. I'm at the table of contents. I'm just trying to see if it makes sense what I'm trying to do, or if I'm gonna have to. I don't know. I don't know if anyone's been I've had this book since May. Did I mention that? Oh my goodness. But this has definitely been a big help. Okay, maybe. But then again, I am dramatic, and also this will eventually be available. It's just gonna take some time to upload and process, and then I have to remember to make it public. So yeah, eventually this will be up there. So you can always go back. Oh, don't you have the power of going back? Oh yeah, that's right. You could technically just go back a bit. And also, if you want double speed, I already talk very fast, so That's probably like quadruple speed, but whatever. Okay, so chapter. Alright, so I'm just starting 2. So then there's going to be 3, 4, 5, 6, and 7. And then there's book 5 has. Book 5 has 5 chapters. 5 chapters, and book 6. Uh, so, hold on. Let me think about the pages. Effectively, I'm just at 450 something. And chapter 6 is going to end by prior to 6:15. That's not too bad. I think it's doable. I hear you. Fine, don't worry about it then. Oh, goodness. All right, so. Oh, no. Oh, I forgot. See, I forgot that was on me. Okay. Non-robot talk. I hear you. That is true. I am not a robot. Nobody could code me. I'm just too much. Maybe AI will have me in like 5, 10 years. But right now, I'm just too much of a mess to be able to be duplicated by some kind of program. Okay, so that being said, I am going to peace out on this stream. And then I'm going to take a little, just brief 5 minutes, give or take, break so I can get my lights set up and this table put away. And then I'm going to hop on a new stream, and it's going to be Groovin' Tuesday live here on YouTube, which will be the premiere of that particular thing. So far, I've only managed to do Sunday live, Sunday dance breaks live here, TikTok, Twitch recently, and most recently adding the Instagram. And then I kind of tried doing Saturday dance break on my Twitch this previous Saturday, but this is my first time trying to do a non-break day, a non-dance break. So hopefully YouTube has some great recommendations of grooving songs. Definitely some Earth, Wind, and Fire is going to be in there. I'm pretty much going to try to do what I did on Sunday. I'm going to put in an Earth, Wind, and Fire song to start, and we'll kind of see what they recommend. And if it seems like fitting with Grooving Tuesday, we'll keep it going. If not, I'll make some adjustments. So the goal is 20 minutes. So if you're interested in seeing some dancing, I'm going to try and give you some dancing. So don't be all, I put on the dancing stream and then you're not even there. That'd be silly. Because frankly, I'm not really feeling it. But since you asked, just be there. All right. So on that note, I'm going to close the stream out. And I got to get some things turned on, splash one on my face. And then we'll do 20 minutes of some dance break. Well, technically it's not dance break. Tuesday Groovin' Live here, premiere, worldwide, kind of, here on YouTube, and see how that goes. Sound great? Oh, no, you gotta be back in 10. The actual thing will be 20 minutes, but be back in 10 minutes. That should give me enough time to do everything I need to do. All right, 10 minutes. I'm going to set a timer. All right. Well, in the meantime, whoever checks this out, look, if you're subscribed, then you should get some kind of notification. Hit that bell, all that jazz. Because I have to set up the room. I have to move the table. I got to move the chair out the way. I got to put the lights on. Take off my coat. My jacket, because I get warmed up when it's dancing time. So that's going to be a little excessive. Anyway, I have things to do. You have things to do. Meet me back in 10 minutes or so. Fine, 12:25. Whatever you need. Bye. And anyone who watches in the future, whatever you're doing, whenever you're doing, make the most of it. I'll see you in a bit, Ryan. Okay, bye-bye.